Well, hi, good morning. Thank you so much for joining me in my shop here. Today it's June 1st and it's Canada Day. You can see I've got a few flags flying in here. So it's a big day for Canadians. We have a holiday and take a big celebration all across the country on Canada Day. Going to be particularly exciting this year, I think, because Canadians are feeling a little more Canadian than they used to. Thank you, Mr. Trump. You've really amped things up in our country, in my country, anyway. Okay, so this radio, based on my somewhat clumsy testing of the antenna, it would appear that there's a problem right at the antenna, and if that could be solved, a strong signal would be passed through the radio, come out the speaker, would sound great. But I can't figure out what's wrong with that antenna. At this point, I haven't found a schematic, and I think a couple of you are looking for a schematic for this radio, but I haven't found one yet. But it's very similar to many other models. I think we could find that many other models are actually quite identical up in this area here. Okay, but in the meantime, what can I do? Well, there's two things I can work on in the meantime. One is testing the vacuum tubes, which I'm going to do today, and change some of these old capacitors which look really terrible. They always seem to look really terrible in this kind of radio. You can see a bit of one sticking out here with junk coming out of it. Not a good sign. Okay, what are you playing with today? A bundle of wire. Bundle of wire. Okay, great. Oh, settling in. He's settling in. I will get my tube tester ready down here, and we'll start testing those tubes. Okay, let's test the first tube. This is the output tube, 6BQ5 or an EL84, either way. I have this set up for a 6BQ5 now. 6.3, 4, 20H, 05176, 05176, 0304, 0304, 30F. We're good to go. Have to give it a moment to warm up. Okay, let's look for any shorts in this tube. Nope. No shorts. Now, the reject point is 1400. 1400, this is 1500 halfway up, so 14's right there. And it's dirty switch. It's good. It's okay. And you know, we heard the radio work with quite substantial volume, so I mean that's a good test too. But yeah, you know, a lot of cases I don't test the tubes in the radios until way late in the game, and sometimes not at all. 6AK8. Okay, 6AK8. So I'm testing the tubes here because I don't know what else to do. 6AK8 or an EABC80. This doesn't have the made in the GDR. GDR. German Democratic Republic. Which part of Germany was that? I'm too stupid to know. Sorry. If you're German, I apologize. Okay. Let's set this up now. So signal level 1. 25L. 25 low. 00076. 00076. And 0153. 0153. this right? 0. It's unusual having 3 zeros here. 760. Yep, that's correct. Sensitivity 39. Whoops, 32. Sensitivity 32. F. Okay, I think we got it. This tests the triode in this tube. This tube's a triode with 2 diodes in it. So it has three tube tests. It tests every part of the tube. And the first part is the triode. Triode part. Again, what are the chances of this not working? Pretty low because the radio produced volume. I know the tube that's probably going to test bad. That's going to be the FM tube, I'm going to guess. Okay, any shorts? No. If there was a short, the meter would come up. And this tube, this test, 910, so just above here. Ooh, wow, she's a beauty. Now, 2 diodes, not really worth even testing, but I may as well do it. 3100. A much lower voltage used in a diode test. So in this tester, rather than looking for a particular number, there's a thing up here that says diodes OK above where my finger is now. So if the pointer comes up above there, diodes OK. Okay. Just check for shorts again. This time we're pushing this button, rectifiers and diodes. And it made it. Okay, and the next test, wildly different numbers here. P3176. P3176. 0K00. 0K00. 38. A. So it looks like we're going to have a nice day here today. Starting out gray and kind of wet from rain overnight, but the sun is trying to come out, and I think it's going to come out later. We'll probably have a nice day. Okay, any shorts here? Nope. Testing again. And of course, much better than the other diode. Much higher test anyway. Okay. Put this guy back. Pick up this tube. This will be the IF amplifier tube. EF89. Okay, so my tube tester port's North American. I mean, EF89 has a North American equivalent. Same tube with just different numbers on it. If that makes sense. I'm going to find out what those numbers are. EF89 is the same as something North American. So an EF89 is the same as a 6DA6. So in Europe, EF89, but here, 6DA6. My tester shows a 6DA6/EF89. It shows them both here. So 6.3 signal level 2, 34L. On the bias, 34L, 05176. 05176. 0342. 0342. 34 D. There we go. So I believe this tube is used as the IF amplifier in the radio. So it's very much responsible for the strength of the radio. I mean, all the tubes and all the parts of it. Oh my gosh. Well, I wasn't ready for that. So you've joined us for the tube test, have you? You have, eh? Any chance you can continue on your way, or go somewhere? Go somewhere else? So I've heard it said, and it's been our experience, that cats have a way of realizing where you're looking, and then if they want your attention, they just get in your gaze. Maybe that's what he's doing here. Okay, we don't really care about this end. Here, look, just step aside a little bit. No, aside means out of the way. Here, I'm picking you up. You can be up here with me, okay? Okay. So we did this. Did we do this? We don't know. Did we do that? I don't know. What are we doing here? We're doing a regular test, 1170. So out here. Oh, she's really good. Okay, you can go back down there yet. Very good. Very good tubes here. Okay, and the next tube would be the mixer tube, I imagine. Let's get it out here. Oh boy, it's been fingered up pretty bad. Not by me. So I'm pretty sure this is the tube number right here. Ugh. It's just a mess. You know what? That can't be the number. That's got to be words. So, give up too quick. Sometimes the number is here, it's just really hard to spot. Made to CGE specifications. Canadian General Electric. No, I don't see the tube number here, but I'm sure we've got it. We must have some information somewhere, do we not? On what tube this should be. Uh-oh. Uh-oh. Is there not a, oh, on the back. On the back there'll be a tube thing. On the back. Look here, let's see. Is there a tube thing on here? Tube chart. No, there is no, oh yes there is, down here. Here it is. Can you see it? It's really hard to see. Just have to get the light on the right angle here. Okay, I can see the. So this tube has come from this end here. Oh, smokes! This is not easy to see. Let's try it with this. So that says ECC 85. That one is the FM tube. And the next tube along, I guess would be this way. This would be the one I'm doing right now. Oh, come on, camera. Oh my gosh. ECH 80. I think it's ECH 80. That makes sense. ECH 80. Okay. That's what we think we got there. ECH 80. Now, the next thing I have to do is figure out what that is in North American talk. ECH 80. Okay. And I think it's a good time for a coffee break too. ECH 80. Okay, 6BL8 is the next tube. And I'm not too familiar with it, and there's 2 tests listed here, so I thought I'd look in my tube book. My old tube book doesn't have this tube in it, so I have to grab my newer old tube book, tube manual. 6BL8, medium mu triode, sharp cutoff. Oh. Sharp cutoff pentode. Wow, shucks. Do I have to go back and edit that? What happened there? And you can see there's two distinct tubes going on here, 2 cathodes, 2 completely distinct tubes. Okay. I guess you can't really say 2 distinct tubes. The glass part is the tube, so I can't really say that. Now I've got this set up here for the first one. 6.34 14L 30076 30076 0015 40 C. Good. So the fact that this tube isn't in my older tube manual means this is a newer tube, a more modern tube, and what was happening towards the end of the tube era was that tube manufacturers were trying to shrink their tubes down smaller, pack more inside the tube, so you get 2 tubes in one, like this one here, and it didn't work in the end. The tubes eventually fell away. There's still certain applications of vacuum tubes, certain areas where they're still used, but not much anymore. I just watched a video on the breakthrough in solid state electronics, in which rather than rely on the charge of an electron to do the work, which is what goes on inside all of our electronic stuff, it's the charge on the electron that we're utilizing to make things happen. In this case, they want to utilize another behavior, one that's called spin, which isn't actually a spin, but they call it spin. And every electron has, it's either a spin A or spin B. It's spin up or spin down, spin left, spin right, however you want to put it. It's one way or the other. That sounded like a 1 or a 0 to me, for sure. And apparently there's been a breakthrough with enabling this kind of computing. I won't go into the details because I don't know the details, but it's just another huge step forward in technology. They're happening all over the place now. We live in a world full of scientists and engineers now, all over the world, and there's just discoveries pouring out everywhere. And better investigative devices, telescopes looking up in the sky, and everything. Everything is improving rapidly. Except the human beings themselves. The human beings themselves seem to be falling apart. Okay, let's go. Here we go. And this tube should come up to, it says 1020. Wow, can you be that precise? Above my finger, she's okay. She's okay. Hold on a second here. Okay, hold the fort. How can this happen? Because I had this set wrong. Let's take a look again. 6BL8. What really counts are these numbers. 30076 for sure. 007. Right. 0015. 0015. That's right. 40. See. Tube is heating. Wow. Well, that's not good, is it? How did this radio work if the tube is dead? Now it's a 2-part tube. Is it possible one part it was doing the FM amplifying and the other part's doing the AM amplifying? So the part with the AM was working, and that's why the radio worked, but the FM, which didn't work because of this tube? Wow, good questions. Who knows? Just making it all up. Okay, I guess we'll do the next test. See what happens with the next part of the tube here. Okay, so now I make a few changes. I'm going to take it out because I just don't feel comfortable changing these with the tube in. 12L, slightly different there. 05476. 05476. 3100. 34. D. Okay, let's try it again. Whoa! What happened there? Okay, maybe this isn't a 6BL8. Maybe this is something else. How can it not be a 6BL8? A 6BL8. Let me just look again and see if I can get these numbers mixed up. 6BL8 is the same as an ECH80. Oh, hold on, there's another tube. 6AN7. What is going on here? So, okay, I'm going to have to look into this a little bit further. I got one reference saying 6BL8, another reference saying 6AN7. Huh, okay, let me look into this a little further. Wow, an ECH80 is a 6AN7. The other reference is just plainly wrong. Okay, that explains a lot. We'll set up for this. 6AN7. 220L 45176. 45176. 0345. 0345. 46 D. Full tube test. It says that this is a two-part tube. This has an oscillator triode in it. Okay, let's plug her in now. See what happens. Boom. Bzz, bzz. No, bzz, bzz. Now, I have a tube substitution guidebooks here. Got about a dozen of these books. But I don't know if they do European stuff. Industrial tubes. Why did they put these here? This section, American receiving tubes. Okay, that's a hint. You can do European ones. Communication and special American substitutes for foreign types. Okay, I've got it here. We're going to look up ECH80. ECH. You really have to know your alphabet, you know. ECH80. 6AN7. What was this 6BL8 thing? Let's do it the other way around. 6BL8. 6. This won't help anything, I don't think. 6B. BL. JKL. I should have studied the alphabet better. 6BL8. 6LN8. I don't know. Okay. My God, there's incorrect information on the internet. Did you know that? Did you know that? Oh my gosh. Okay. So we're doing the shorts test and we've got a short indicator here. Sometimes they'll put a note. There's no notes. Yeah. what do you do about something like this? Double check all this stuff again. So signal level 2, 20 out, 45176. 45176. 0345. 0345. And the rest doesn't really matter because of this. Oh my gosh, I shouldn't have pushed that button. This is the one I should be pushing. This actually gives a resistance reading of the leak. According to it, this is about somewhere between 500,000 and 1,000,000 ohms leak. I mean, on the face of it, the tube cannot be used because of this. 6A and 7. Do I have any of these tubes? Okay, I'm going to take a look. I guess it's time to get smarter about the leakage test on that particular tester. This is the manual that comes with that tester. It's the Weston 981. It has a fairly long section here on doing the leak test. Tube checker is now ready for operation. Leakage test. Leakage testing is controlled by the leakage test switch, which in its numbered positions disconnects all the tube elements from the other testing circuits and connects them into the leakage test circuit. The meter deflection in each switch position is indicative of the resistance between the isolated element and all other elements of the tube. For this circuit, the meter deflection is inversely proportional to the leakage resistance. A full-scale reading indicates 0 resistance, as marked on the meter scale. Resistances as high as 10 megohms can be measured. The element checked for any position of the leakage test switch is shown as below. I give a little chart here. Now, one of the things I've never really paid attention to this. I've used this tester hundreds of times. You kind of think it would be tube test and then 1, 2, 3, 4, 5. But in fact, it's tube test 5, 4, 3, 2, 1. And position 1 is important in the scheme of things, as I've discovered, because I pre-read this quickly. So in the case of the tube I'm testing, I'm getting a short indication, partial short indication, at settings 4 and settings 5. So settings 4 is screen, grid, and all other elements. So I've isolated the screen grid. Number 5, control grid, and all other elements. I've isolated the control grid. So if 4 and 5 show a similar effect, then I think what it's saying is the screen grid is shorted to the control grid. They are adjacent to each other, or is partially shorted. So there's some kind of conductive path inside the tube now between these tube elements. A low or 0 resistance indication for position 1 is normal for tubes that are of the filamentary type or have an internal heater cathode connection. So in some tubes, rectifier tubes, the tube tester warns you that when you do the short test, you get to position 1, it'll show a short because there should be one. The red line on the leakage scale is at the 250,000 ohms mark. I've never noticed the red line on the leakage scale. You know, I left that tube under test in there. I left it under test, and look what's going on here. I just kind of abandoned the whole thing here. Let's see. I see the pointer. Watch the pointer. The pointer's right here. And you're not going to be able to see it on the camera. What I can see, it's doing this. It's jumping around. That's an indication, again, of some kind of path inside the tube. That didn't do anything. That is kind of random. So it'd be like a carbonized path or something. I don't really know how a tube develops a short inside. I don't know. It'd be over a surface. Surfaces are, you know, the interface between any two materials is a shockingly exciting chemical chemistry lab. So where air meets a surface, like where air is meeting this, there's a lot of chemistry capable right at the interface. So electrically, when you're talking about shorts, if there's a surface involved, the surface is easy to short across as compared to just going through air or going through vacuum. Can you short through a vacuum? Don't say too much more, Jim, because you're starting to sound like you don't know what you're talking about. Okay, here we go. The red line at leakage scale is the 250,000 ohms mark, which is the approximate value that causes a neon bulb to light in a conventional short circuit test. Now, the reason they're saying this is that they're saying this tester with its meter will show you things you can't see with the old tester with the neon bulb. And the old tester with the neon bulb might not light, and so you're thinking there's no short. Meanwhile, in this tester, you can read a value. That's what's happening right now. We're reading a value. It's not a solid short. Would it turn on? Where is the red line? I should really turn this test off too. I don't see any red line. I don't know what they're talking about. The only red line on this thing is right in the middle for the line check voltage. Red line. So I don't know what they're talking about. But why do they need a red line? They just told you the number anyway. 250,000 ohms. So 250,000 ohms. Oh, there's a little red line there. How do you like that? It's so small. It's not. No one's even going to know it. Okay. So we can interpret this that way. In fact, according to this, if I put the tube in another tester, I have one with a neon bulb, it won't light the bulb, and I'll think there's no shorts. So if I did this with my 966, I'd say the tube has no shorts. If I do it in this one, I say it's got a short. Let's keep reading. Refer to the roll chart data tube to be tested. Turn all the stuff. Oh, a GM test. Was that it? Oh, down here. I've never followed this practice. Set leakage test switch to position 1 and insert the tube in the proper socket. I always insert the tube with the switch in the tube test position, then I rotate it 5, 4, 3, 2, 1. But I think what they're saying is set it on 1 and rotate it 1, 2, 3, 4, 5, and then tube test at the end. So you never have this thing set in tube test until you've gone through the shorts. But that's the proper procedure, and I'm not following it. Shame on me. This is the important point now. Turn tube tester on, allow tube to warm. Pull down line check switch and adjust meter pointer to get the line adjust correct. Rotate leakage test switch through positions 1, 2, 3, 4, and 5, tapping tube lightly for each position of the switch. I seldom do that. Why do you want to do that? You might make the tube short out. If meter indicates less than 500,000 ohms, and in our case, it's more than 500,000 ohms, the tube should be rejected. Oh, so now what they're saying is, you see, this tester can spot defective tubes better than the neon bulb tester. That's the message in here for selling this thing. If maybe they say it in ordinary English somewhere, but these are competitive machines, and a lot of them do have just a neon bulb. So why do you buy the Weston? So you can find this guy, because you can't find him on your neon bulb tester. In certain critical applications, such as audio preamplifier stages or certain TV circuits, the heater cathode and or inter-element leakages cannot be less than 2 megohms. And we're less than 2 megohms. 500,000. So we're right in the ballpark here. I think we're around 750,000. With leakage test switch in the tube test position to press the, go ahead with the rest of the tube testing. Diode and rectifier tubes. I think it's the same thing. It's the same thing. Okay, there's the story. The tube is showing a partial short. We're going to stick it in another tube tester and with a neon bulb and see what happens. So let's just repeat the test here again. So we go there and we see it. It's, yeah, 750,000 ohms. It's drifting up towards a million. Interesting, it's going higher. We have virtually the same reading in these two settings, meaning it's probably seeing the same short, and then the rest of them are zeros. Do we test it? They didn't say don't test it. I mean, if this thing came right over to 0, I would not want to test it. Is the test valid with a short in there? Didn't really say. Well, it didn't really say clearly what to do if it's above the limit they were suggesting, which this one is. So they said 500,000, and this one's 750. It's above. Let's throw the button here. I did it once already. Nothing bad happened. And this test should show 850. So, you know, way down here is the reject point. It goes way over. Okay, let's do the other part of the tube here, and then we'll try a different tube tester. 10L. So nothing interesting will happen today when I do these tests. 0, 0, 1, 7, 6. 0, 0. Take the tube out of there. Jim. 1, 7, 6. Some tube testers you can change these with the tube in. The tube only connects when you push the button. The other tube testers, you cannot change these with the tube in there. And I don't know which is which. So better safe than sorry. Okay, 00176, 00176, 0035, 0035, 32, C. Oscillator part of the tube. This tube is hot now. It's a hot one. It's a hot one. Oh, this should have been. I'm gonna snap it over to 1. It'll take me a while to learn the new procedure properly. Okay, here we go. Will we see the same short? 3. This is coming up a little bit too. It's 5 megohms here. 4, nothing. 5. So clearly something has happened inside this tube that's developed conductive paths between all the elements in the tube, many of the elements. Okay, and if we test this one, 9, 9, 10. So 9, 9, 10 would be about here, right over. Okay, well I'm going to get another tube tester. We're going to test the tube testers and see if that will light the neon bulb. Okay, so this is one of my other highly reliable, trusted tube testers, and I've looked up 6AN7. No, I haven't, because it doesn't have it. It doesn't have a 6AN7. 6AN4, 5, 8, no 7. So I was going to look at the supplementary list, which what I would normally do. I have a supplementary list that came out after this was built, right? They would publish supplementary lists. But I'm going to ask Copilot if it knows. Let's just find out. So I'm just going to switch on Copilot over here. Something went wrong. Reconnect. One moment. That's on me. There was an error. Try reconnecting. And there's the answer there for today. You know, this happens a lot now. I try to use the Copilot audio that I'm trying to use right now to talk to it, and this is what I got. Let's try once more here. Let me click that. We'll click this. No, something went wrong. So they have their problems with trying to keep these systems going, and I think it may have something to do with the large demand for computing power. I think these things are outstripping the existing capacity for computing power, and we see the big companies scrambling to try to build data centers. I think it's all about doing exactly what I'm trying to do here. Okay, so that's not going to help. So I'm going to have to look for the supplementary list here and do it the old-fashioned way. The old-fashioned way, looking on the internet. So you might hear the air conditioning in my house running now. So this didn't work out. Supplementary lists don't contain 6AN7 and don't contain an ECH80 either. Can't find it anywhere for this tester. And so I checked another tester, that's a third one, not listed. So I think we're just going to have to accept the tube the way it is. It did pass the actual test with the other tube tester, and I have none of these tubes in my stock. And so I really have nothing more I can do than that for now. That's really, I don't like it, but it is what it is. So that leaves one more tube to do. The last tube will be an ECC 85. Okay, so let's get set up for that. Okay, I have found a listing I can use on the 966 here for an ECC 85. So 6.3 and then EV7608. So 6.3 then EV7608. The 0 here, I think, yep. 11 and 85, so bias 11, English 85. Put the meter setting to the 3000 scale up here. This is a there's two tests. It's a dual dual triode, same tube twice inside, if you like. And just double checking, 7608. 7608. Good. Okay. Here we go. So in my experience with these European radios, many of them have the same tube in the FM front end, and it's often bad. So maybe I should have started with this, just like the other tube tester. I really should have had the short test set to 1 when I put the tube in. But we're not going to worry about that. This tube tester for sure, unless you push this button, there's no voltages applied to the tube except for the heater voltage. Okay, so we'll look for shorts. Now we're watching a light in this case. It's a very weak flash. Oh, it's on here. And right on 3. You see that it's on? It's very hard to see. Yeah, you can kind of tell it's on just a wee bit. Another leaky tube? How can this be? Now we know from the other tube tester, the hint was, man, if this light comes on, you got a pretty good leak going in there. That's what the other tube tester was suggesting. I think that's a pretty minor leak myself. Okay, so this tube is supposed to, on this set test, 2580 at the bottom, 4100 when it's new. 2580. So on the 3000 scale, 2580 is way up here. So this is the reject point. So I'm going to go to the 6000 scale, and 4100 is like new, and about a little more than half that. 25. Throw it away. Are you ready? Nothing happened at all. Is this tube even heating up? It does not appear to be heating up. I do have the tube tester on. I'm making that mistake. And the heater connections are here. This is EV, just as requested. 6 volts, just as, oh, it's heating up now. So it's making bad contact in my tube tester. Yes. Let's try again. Now we think it's working properly. We'll do the short test. Now we're getting a strong flash here. Flash is good. If it stays on, that's a problem. Nothing's staying on. Now we're going to push the test. And once again, the reject was it's on my computer here. Reject is 2580. So I'll put my finger there. On the 6,000 scale, 2580 is about here. That's not 80. Right on, right. It's just below. So 2580 is throw it away, and this is coming up at 2100 on this tester. Let's check the bias sensitivity here. Well, yeah. Well, the most we can say about that, I think, is that it's weak. Now the next setting is 2103. 2103. I can leave the tube in on this tube tester. 2103. Is that right? Let me look again. 2103 with a 0. 2103 with a 0. And 1185, same settings here and here. This English setting only matters when you have this control set to English. Then you just read these words. But we're being more technical here. We're going for numbers. And the numbers are the very same again. It's the same tube. Same type of tube inside. Shorts. Again, we got a little bit of a glow there. I put it in the other tube tester, but I can't find the settings. Okay, this has really been surprising. So here we go. So again, it's supposed to come up to 2580. 2580. It's 3000 right here in the middle. So 25 right there. Wow, it's weak. Well, it may be enough to make the radio work. It may be too weak for the FM to work properly. We will have to find out down the road. But for now, I'm going to put it back in. The tube is working. It's just not strong. It's an amplifier tube. I don't think it's involved in any kind of oscillator stuff or anything like that. I think. I could be wrong about that. So if it's just amplifying, then all it can be is weak. Put it back in. As I'm doing this, I'm noticing how the antenna is so loose here. I'm not getting this tube in. Just like that. It should go right in. Right in. Just like magic. You just drop right in. There it goes. There we go. Okay, like magic. I noticed this just wiggling away in here. Look at it. So both these tie wraps have come off. Now maybe that's because of me fooling around. Tie wraps. I think that's a sign of something. Get this antenna out of here. Yeah, we're leaving the tube situation now. We're moving on to the antenna situation again. Did this come from another radio? It says 2 rubber bumpers here. They seem to be in the right place. There's no other sign of how this might have been held on, except for these 2 tie wraps. This coil, I think I tried. Oh, it does move. Oh. Okay, so the position of this coil is critical. There's probably 2 coils in here, isn't there? So I see 2 wires here coming out here. So it looks like this is 1 coil. Oh, it's a piece of cardboard. Huh. 1 coil. Isn't that a little odd? You usually have 1 coil you resonate and another coil you pick up. And the pickup one is the one that connects into the radio. So if this hasn't been changed, which I kind of doubt, probably see it in these wires, but they look like they're from the factory. Another broken wire I didn't see. That could easily be the case. Another broken wire somewhere. Also, this solder job somebody did over here may have done bad things. What bad things? I'm really hoping to see something, but I don't think I'm going to. There's a divot in the rubber here. Why is that? Is that from this? How to get the divot? I'm going to break these wires for sure if I keep doing this. So the reason I'm talking about the divot is that indication this is from another radio. If this is from another radio, then what are we doing here? Good question. The other thing too was the fact that this is waxed and this one appears to be cleared out. Or was there just never a slug in this one? The bottom of it is weird. It has this weird, what looks like a soldering iron strike on it here. Right in here. There's that sign of somebody doing something. Is there a wild chance this whole piece came from another radio? It's kind of loose on here. I doubt that very much though. Like if you had another radio and it had the piece that you needed here, it would probably have all the rest of the radio too, so why not just use the other radio and abandon this one? It doesn't make a lot of sense to transfer a big chunk of one radio to another. They all have problems everywhere. Yikes, there's another coil down here which really looks like it's been out in the weather. I'm gonna switch to the close-up camera here and get a better look. I think I'm about to have a cat join me. Oh, it's Wally. Wally's here. Oh, he's leaving. Okay. So I just noticed this coil way out here. Way out here in the boonies. What's it doing way out here? Like no one's fiddled with it, or is that fiddling on the top? For some reason they've stuck this coil way out here far from the, they've banished him to the end of the radio here. We don't really know what's underneath in this area. And then this is all looking pretty rough. Spider there. Could say this radio's full of life. Well, it's full of death now, isn't it? A little window here to peek through. Here's my focus knob. Here it comes. Is that a coil? On the left there, that might be a coil. Another little window to look through. That's a coil, I think. Yeah. Why maybe these are portholes here are for no good reason at all. So I'm just getting distracted here because I don't know what to do about the real problem. The real problem. So now, did I maybe solder this and I didn't succeed? That's right here. It looks pretty good to me. But that would be a possibility, that I soldered this and did not succeed. How can I prove it? I have to ohm it out somehow. I have to find the other end of. Oh wait a minute. This now wait a second. This wire that I resoldered is coming over here. But I found from touching stuff that these weren't very sensitive. When I'm in the AM, it's this other side that's extremely sensitive. You see the big coil here kind of hints at AM also. And we're thinking this antenna's designed to run both long wave and broadcast. Is that so? Is there a long wave band on this radio? Let me look and see if I can use this camera. I think I'd know what bands are on this radio. Oh my gosh, how's this tangled up in here? Sorry about that. Did you fall out of your chair? No. Well, after all that, I forgot what the heck I'm doing. What was I gonna do? I don't know, let's look at this in the meantime. Look at that capacitor. It's just puking its guts out there. And this one. Oh, leaky, but the radio's not humming, or maybe I just haven't noticed the hum yet. And then there's that through there. You can see the electrolytic capacitor, almost certainly the FM detector capacitor. And what other oddball things do we see here? There's a resistor with a hole in the end. That hole can indicate trouble. There's another one with a hole in the end. Right down here. So I don't think they had the hole when they were installed, or I think the installer would have said, "Ooh, I'm not installing this one." So he said, how would it get a hole there? A hole would burn through from inside, because of a bad connection of the lead coming out of the end of the capacitor or resistor versus the stuff inside can get through there. Yeah, these look nice. Okay, well, I was going to do something really exciting there, and then I forgot, and I have not remembered what I was going to do. Jeepers creepers. Yeah, maybe I'll go have some coffee. You might be reaching the end of the line here today because I'm reaching the end of the line. Okay, I'll drink some coffee, see if I can remember what the exciting thing it was I was going to do, and if not, then I think we'll call it quits for today. Tie wraps were invented in 1958 to solve aircraft cabling problems. And the first year or two, I'm sure they didn't look anything like this. Now, this has probably come much later. This is what we're used to seeing. This is what we get today. When was this radio made? Right around 1958, I'm not exactly sure. Somewhere in that range. Is this from the factory? You know, I don't think so. There's something weird about this antenna. Somebody did something, didn't work. They found they could stick a wire here and hang it out the back. Good enough, moving on. That's probably the story. It's not totally believable. That's the best story I've got now. So what am I supposed to do about it? Well, that will be the question. Maybe tomorrow we'll look at that a little closer, or I'll just maybe we'll consider all this stuff while I'm busy changing out capacitors here and there. And we'll see what we can do. But unless we can solve this antenna problem, there'll never be a strong enough signal for this radio to work well. Even hanging a wire out the back, it's just it's AM radio. You really need a loop antenna to get a better signal with less interfering noise. Oh boy. Okay, well, thanks a lot for watching. I'm going out to enjoy my Canada Day here. It's a big day here in Canada. It really is. Bigger than ever. See ya.